Hey guys, welcome to the last little section of chapter 9. What we're going to talk about in this section is a little bit more about solubility, so the ability to dissolve in solution, and then some things we can do to affect the solubility, so make something more soluble or less soluble. So solubility is the amount of a compound that dissolves in a certain amount of liquid. And usually we would measure this in grams. So back to our classic sweet tea example, we could think about the number of grams of sugar that we could dissolve in a cup of tea or a gallon of tea, whatever way you want to think about that. If a solution is saturated, it is holding the maximum amount of solute that it can possibly hold. It will not hold one more particle of solute. If it is unsaturated, the solution is holding less than the maximum amount. So think about making sweet tea and assume you're a Southerner. So you've got this gallon of sweet tea. You add a little bit of sugar, you stir, it dissolves. It was unsaturated, it could hold some more. You add some sugar, you stir, it dissolves. Still was unsaturated. We put more in and it could take on more. Finally, we pour some sugar in, we stir, a little bit dissolves, and the rest just kind of settles down at the bottom of that gallon of tea. We know at this point that that tea is now saturated. It's holding the maximum amount of solute. It doesn't matter how much you stir or how much more sugar you pour in. It is not going to dissolve another grain of sugar into that tea. So that would be a saturated solution. What we're going to talk about now are some ways that we can affect that saturation point, affect the solubility. What if we want to add more sugar? What if we want less sugar to dissolve? How can we affect that? So the first thing we're going to look at here is temperature. So on this graph, we see down here as we move from left to right, the temperature increases. And as we move from the bottom to the top, our solubility increases. So the amount that it can hold in solution increases. And what we see is as we increase the temperature, for all of these, the solubility goes up. So we see positive slopes for all of these. So that tells me that the solubility of most solids will increase as the temperature increases. So we increase the temperature and we can put more in. If you've ever made sweet tea in the South, this is likely something that you did to get more sugar in there. So you poured sugar in, you stirred, you saw that it was saturated, the extra sugar floated to the bottom. Then you put that gallon of sweet tea on the stove, heated it up a little bit more. When you stirred this time, that sugar then dissolved. Now your sweet tea is finished. It's oversaturated. So by increasing the temperature, we increase the solubility of solids. We could talk about the opposite as well, so I don't have it explicitly stated on this slide. But if I decrease the temperature, so if I'm trying to make tea while it's cold, ice cold, it's not going to hold as much sugar. So if we decrease the temperature, we would also decrease the solubility. So this works both ways. Okay. Now we're going to talk about the effects of a gas in solution. So think about boiling a pot of water. Have you ever boiled a pot of water and right before it does that rolling boil, right before it kind of goes into its rolling boil, you see these little dots or bubbles on the bottom of the pan. Those little bubbles or dots on the bottom of the pan is actually gas that was trapped in that water. So when you pull water out of your tap, there's nitrogen, there's oxygen that's dissolved in that water. But when you start to heat it up, that gas comes crashing out or falling out of solution. So what this tells us is that the solubility of a gas will decrease as the temperature increases. So as I warm up that water, it no longer can hold on to those gases, so they come bubbling out or crashing out of solution. Okay. So this one is an inverse. One goes up, the other goes down, one goes down, the other goes up. Another example of this exact same principle is thinking about warm soda versus cold soda, or if you've ever worked in a restaurant or bar industry, you can think about beer as well. So if you think about pouring a beer or even pouring soda, do you keep the tap lines warm or do you keep the tap lines cold? Yeah, you keep the tap lines cold. So if a soda is cold, when you pour it or you fill it up from the tap, you'll see that more of the gas stays dissolved in solution and you won't get as many bubbles on the top. If we allow tap lines or sodas to be warm when we poured them, what we'll see is lots and lots of bubbles on the top of our drink, and that's not what we want. We want it dissolved in our drink. So cold tap lines, the gas stays dissolved in solution. Warm tap lines, we get lots of bubbles on the top. So that's solubility and temperature. The last thing that we're going to talk about is solubility and pressure. So think about opening up a can of soda. So when you open up a can of soda, what happens is pressure is released. So inside of that can, you've got a pressurized system. The pressure is really high. When you open up that soda, the pressure inside of the can goes down. It goes way down. So you go from a pressurized system to just open pressure. The pressure goes down. So what happens to the gases inside of that solution? Well, what we see is that our gas comes crashing out or bubbling out again, right? So here's kind of a dramatic picture of it, and here's a less dramatic picture. So for some reason, this is given a name. It's called Henry's Law. But Henry's Law tells us that the solubility of a gas is directly related to the pressure. So when the pressure goes up, the solubility of the gas also goes up. When the pressure goes down, the solubility of that gas also goes down. Okay? So in a pressurized system, the carbon dioxide, the gas inside of the soda, was dissolved in solution. When we decreased the pressure by opening it, that carbon dioxide is no longer dissolved. It's coming crashing out of the solution, and we see those bubbles kind of rise to the top of our can. So that is it for chapter 9. Like I said, it's a fairly short chapter. You also have to make it through chapter 10 before this module is over. But that is it for chapter 9. I hope you guys found this helpful.